We'll move on to the next topic, which is lightweight vertical solar for flat roofs and green roofs, and then also introduce myself properly. My name is Trygve Mongstad. I'm the CEO and the founder of this company, which I started 5 years ago, based on my experience as a solar installer, but also as an advisor to building owners. And I wanted to develop this unique product that would enable basically more buildings to install solar, also where it's not possible with the conventional solutions today. So that's kind of a common background for all of the companies here today. The problem statement that all buildings don't really have solar. And of course, for someone coming from the solar sector, we want this to be not to be the case. We want all buildings to be able to install solar. And contrary to what many people think, it's not only financial constraints that is holding back investments in solar now, it also is quite a few technical problems. Also importantly, as a backdrop for the companies presenting here today and you as participants, in less than a year from now, from January 2027, all buildings that are entering into the planning phase, commercial and public buildings above a certain size, will require to have solar panels as a part of the solution. Of course, we don't want all buildings to look the same. So we need solar solutions that adapt to the buildings and the architect's needs, and not only the other way around, to adapt all buildings to the conventional solar panel. The countries are now preparing, as we speak, the implementation of these guidelines and requirements of the European Building Performance Directive, so that we will know within the end of the year how this exactly is going to be in each and every country. And it's going to be stricter and stricter, also touching upon existing buildings and residential buildings with time, that all buildings really need to have solar. And this will, of course, change the dynamics of the solar market to a great extent. Coming back to over easy and what we do solar solutions for flat rooftops. And here you see some examples of the technical problems with flat rooftop systems. Normally, flat rooftops are mounted with solar using ballast. You add something heavy, concrete blocks, in order to keep the panels down the roof so that they don't lift off and blow away in the wind, because I also don't want to fasten it to the building or penetrate the building envelope normally. Some cases you do fastening to the rooftop. This is an example of a solar installation that is fastened to the rooftop, but you here create a huge maintenance problem. If this were an existing rooftop with an unknown remaining lifetime and a risk for leakages, you here block the whole surface, and you run into big problems if you have a maintenance need anywhere below this surface of solar panels. There are other examples like white roofs or cool roofs that are built in order to keep the building cool, to reflect the sun off the surface instead of absorbing it, like most rooftops that are dark will add heat during the hottest day of the year. Cool roof is made to avoid this effect. But if you add black solar panels on top of a cool roof like this, it's not a cool roof anymore, and you destroy that function. My favorite category is green roofs, bringing in a lot of qualities to urban areas like water retention, temperature control, and biodiversity. But again, if you cover these green roofs with black solar panels, it's no longer a green roof, and it doesn't provide those functions that it so beautifully should provide. So our solution is what we call the vertical photovoltaic unit. It's a pre-assembled plug-and-play unit with 4 solar panels in a mounting structure. You basically get 62 square meters of solar installation ready on a pallet. Each unit has 256 watt peak and over 95% bifaciality on the panels. And it's a very simple mounting process. You basically lift them up off the stack that you see here on the right-hand side. It comes delivered to the site on a pallet like this, and you put it into the final installation site and connect it to the neighbors in the installation. There's no other way, basically, to make a solar installation on a flat rooftop as quick as this. Many people ask how this is possible to mount on a rooftop without any fastening or ballast. And the answer lies in the design of the product. So because of the vertical components, there is no lift force generated. So it cannot really, there's no pressure difference above and below the units, and it doesn't lift off in any kind of circumstances. Also, the solar panels are small and spaced densely together so that we have very little wind forces between the panels and low push forces. So almost in all cases, we will be able to build an installation that is not fastened to the building and does not require any ballast, giving a lightweight and easy mounting system to work on these rooftops. Obviously, we do an assessment in every case to make sure that we meet the local requirements for wind load. Another question that is natural to ask is how can these panels produce efficiently their energy? Because it's vertical. Most solar professionals know that vertical orientation is not optimal for solar panels. However, the answer is that they have two sides, so they add up pretty good energy production. And it depends, of course, on the location where it is, the albedo, which is the reflectance of the surface below, the azimuth, which is the angle, let's say if it's eastern, southeast or south oriented, and the shading for local conditions. And you see two examples of energy yield results here in terms of specific energy yield is kilowatt hours per kilowatt peak over a year. And as you can see in the north of Norway, for example, we will in any case always generate more energy than a conventional flat roof solution, even with low albedo rooftop. For southern more locations, the albedo becomes more important, and with a low albedo membrane, you will get a little bit less energy yield over the year, but with a high albedo membrane, you get in total a very good energy yield over the year. Importantly also is that vertical solar produces energy at times where the energy is more valuable. One aspect is that it produces more energy during the winter time. So you can see here graphs for per month over the year, and you can notice that the orange and yellow graphs, which are the VPV solutions here in different azimuths, both deliver in both locations more energy during the winter months of, let's say, January, February, March. They also, vertical solar also delivers more energy during times of the day when the energy is has more value. So you see with the east-west orientation, you will get two production peaks like this, one in the morning and one in the afternoon, matching better with the power price pattern, which has one peak typically in the morning, lower prices in the middle of the day, and high prices in the afternoon. Conventional mounting of solar panels, on the other hand, generates most of the energy during the middle of the day when the power prices are at their lowest. We have also a software that makes it quick to make an estimate and a proposal for a project. So in case you want to test it out, please feel free to forward us an address. We can do a quick assessment and a test and give you a full list of all the components needed and also an estimate for the energy yield for this site. So we have now several installations in different locations. Here you see some examples. It's public buildings, schools, it's offices, logistics buildings, even a sports arena you can see here. And it's mounted on regular bitumen rooftops, white roofs or cool roofs, green roofs. So it goes with a lot of different types of rooftops. Gravel roofs is another example where sometimes conventional solutions can be difficult to mount. You see a couple of examples here. It also works at different scales, so we have delivered both to residential buildings and huge logistics buildings. So it works on all sizes. We've been delivering this solution now 2 years as a commercial solution on the market, delivering to about 50 projects in 13 different countries, and covering now around 20,000 square meters of buildings with our solution. Just to quickly go through the main best projects for the DPV unit. Green roofs, that's my favorite, as I mentioned, where you can still keep access to the roof and maintain the green roof qualities. Low load bearing rooftops that cannot take the weight of a ballasted solution. Short membrane rooftops where the maintenance need is in high focus. Gravel rooftops, cool roofs with a white membrane, and harsh climates where you get a lot of snow, a lot of wind, or a lot of both of those things. So I'm going to round off now. Here you just see an example of one of the largest installation that we have delivered to so far. It's about 3,000 square meters on a logistics building in the north of Norway. Here the motivation was mainly the last one that I mentioned. It's a harsh climate, it's close to the sea, I get a lot of snow, and the vertical panels provide a better technical solution.